In today's tutorial, we'll walk through creating a scene that uses iterated transformation to create a fractal effect. The focus here is going to be on building the scene, so we aren't going to get into the theory and mechanisms involved. If you're interested in that stuff, check out the videos in the RayTK intro series. We'll be using RayTK version 0.35, so make sure you're using at least that version. Check the video description for a download link. Start by dropping the toolkit talks into your project. I like to do that at the root outside of the main project comp, but you can put it wherever you want. First, we'll set up the renderer, camera, and light. Then we'll create a 2D SDF and feed it through an iterated transform. Then we'll add some radial symmetry. Then we'll extrude that to create a column. Then we'll add a material, and finally, we'll animate some parameters. We'll start by setting up the renderer. Open the palette using the Alt-R shortcut, and create a RayMarch Render 3D. Then create a null top connected to the output so you can see the rendered image. Select the renderer and open RayTK's Editor Tools menu with Alt-Shift-R. And under Add Camera, we're going to choose Look at Camera. On the camera, let's set the FOV angle to 60. And we can keep the default position. Then select the renderer again and open the Editor Tools with Alt-Shift-R. And then under Add Light, we're going to choose Point Light. And on the light, let's set the position to around -8, 4, and -3. The SDF in this scene is going to be created using a 2D cross-section that will extrude vertically. So first we need to create that 2D SDF. Open the palette again with Alt-R and create a blobby cross SDF 2D. Let's now create a visualizer so we can see what this cross-section looks like before we extrude it into 3D. With the blobby cross selected, open the Editor Tools with Alt-Shift-R and choose Colorize 2D SDF. Then with the Colorize selected, open the tools again, Alt-Shift-R, choose Add Render 2D, then select the Render 2D, open the tools again, Alt-Shift-R, choose Append Null. On the Render 2D, let's drop the zoom to around 0.3. That gives us a wider view. On the blobby cross, let's increase the tightness a bit to around 0.9 and the rounding a little bit up to around 0.3. That gives us a fairly narrow middle without the shape disappearing completely. We're going to be applying a ton of transformation to this shape, so the exact shape here is only going to be distantly related to what comes out the other end of the pipeline, but this is a good place to start. Next, we'll apply Iterated Transform to turn this shape into a more complex fractal-like pattern. The Iterated Transform operator is covered in more detail in the recent video in the intro series. In this video, we'll just walk through the steps needed for this particular scene. So if you don't want to watch the intro video first, that's okay. But if you want to get a better understanding of how it works, I recommend watching that video in the intro series first. Open the palette and create an iterated transform. And we're going to insert that between the blobby cross SDF and the colorize. On the iterated transform, increase the X part of the translate to around 0.2 and Y to around 0.15 or so. Then for the Z part of the rotation, let's increase that to around 10. As we discussed in the intro video on this operator, applying rotation before an iterated transform is a good way to add continuous motion to a shape. So let's create an axis rotate operator and insert that before the iterated transform. Try adjusting the rotate parameter there and see how it gives us an interesting continuous motion while the general structure of it stays kind of the same. We'll add some animation to this later on, but for now I'm just going to leave it at 0. Right now we're using symmetry on both the x and the y axes in the iterated transform. But it would be nice to have radial symmetry instead. As we discussed in the intro video, we can provide our own symmetry using the custom transform field input on the iterated transform. Set the reflect mode on the iterated transform to none. Then create a position field and create a modular polar connected to the output of the position field, and then connect that modular polar to the custom transform field input on the iterated transform. And note that depending on which version of the toolkit you're using, these inputs might be in a different order, so just make sure to mouse over it and be sure that you're connecting the right one. Right now, we're seeing places where the SDF is getting cut off in the middle, which is going to cause problems when we start using it with ray marching. So on the modular polar, let's switch on mirroring. It would be nice to have the radial symmetry centered on the middle along the y-axis. So to do that, we can use the rotation parameter of the modular polar. So if you try adjusting it so that it lines up correctly, you're going to end up at 30 degrees. It's 30 degrees because we have 6 total repetitions, and the mirroring means that we need to divide that by 2. So we can use an expression to make sure that we're always rotating the right amount for however many repetitions we're using. So in the rotate parameter, let's add an expression, 360 divided by me.r.repetitions divided by 2. Or you could do 180 divided by part of repetitions. Try changing the repetitions to something like 8 or 12, and you're going to see how it's always centered along that y-axis there. But note that since we're using mirroring, we need to keep that to an even number. So if we were to do something like 5, then you're going to get some kind of weird behavior with it being cut off in the middle. So let's set it to 12. Now on the iterated transform, try changing the z rotation. And we get some interesting behavior there. Let's go back to a value of 10 for that though. Now that we have our 2D SDF set up, we can extrude it into 3D. Go back to looking at the output of the RayMark render 3D. With the iterated transform selected, open the Editor Tools menu with Alt-Shift-R and choose Extrude. So the Extrude option is going to be available when you have a 2D SDF selected. Let's then connect that extrude to the first input on the renderer. What we're going for here is sort of a vertical column that goes infinitely far down and then stops in the middle at 0 on the y-axis. So first we know that we need to change the axis on the extrude to y. To control where it goes vertically, we can either have it be infinite or finite. But neither of those options is what we're going for here, though. So instead of trying to get that behavior directly from the extrude operator, We can make it infinite, so switch that on, and then we can use another operator to cut off the top portion. Let's create a knife operator, and we're going to insert that after the extrude. And let's change the keep side to below the plane. And to get a little bit of a wider view, let's go over to our renderer and the camera. And we're just going to bump that up on the y-axis a little bit to around 2. So what we have here is basically what we're going for, with the shape continuing forever down, but then stopping right in the middle. Now, it would be nice to have it sort of taper off rather than just using a hard cut. Depending on which version of the toolkit you're using, the knife operator might have a smoothing parameter. If so, you can just use that. If it doesn't, like in the version that I'm using here, we can make our own equivalent. So create a plain SDF, and then select both the extrude and the plane. Open the editor tools with Alt-Shift-R, and then under Combine SDFs, choose Smooth Difference. And then let's connect that combine instead of the knife. And then on the plane, let's switch on the flip so that it takes the bottom half instead of the top. So this is actually the same thing that the knife operator is doing internally. So it defines a plane and then does a combine with wherever the input is. Using a combine like this gives us customization on how it does that blending, and it gives us option for a blend radius here. So I think we can keep that at the default of 0.5. Next, we'll add some rippling to the shape by varying the height of the plane that's cutting off the column. So we can get rid of our knife operator, unless you opted to use that instead of the combine in the plane. And let's now use a wave to offset that plane vertically. Create a wave field and connect it to the offset input on the plane. Or if you're using the knife operator, it should have an offset input as well, and you can just use that. Drop the amplitude down to around 0.3. This gives us a ripple along the x-axis, but what we want, I think would be better, would be to have it coming out from the center. And when we do that, we want it to only consider the x and the z axes. Since the wave field doesn't offer a setting for doing that itself, we can use another operator to drive the wave. So create a point distance field and connect it to the coordinate input on the wave field. And then on the point distance field, we can choose x and z. And you can see how that got rid of a few odd render glitches that were happening in there. So now on the wave field, we can use the phase to cause that pattern to come inward or outward from the center. Let's increase the wave period to around 3 to make things a little bit smoother. Now we can adjust that period, it gives us a nice smooth motion. Next, we'll set up a material. Create a modular mat, and we're going to insert that after the combine or the knife, depending on which one you're using. With the modular mat selected, open the editor tools with Alt-Shift-R, and then under Add Diffuse, we're going to choose Orange Iron. And then let's select the modular mat again, Open the editor tools with Alt-Shift-R, and then under Add Specular, we're going to choose GGX. And this is a pretty standard combination that I tend to use in a lot of scenes. On the diffuse, let's increase the albedo up to around 1. And then on the specular, we can increase the roughness to around 0.9 and the Fresnel to around 0.8 or so. Now we can pick 2 colors for the different shading elements to help differentiate them. So on the diffuse contrib, let's pick color, and I'm going to go with kind of a pale blue. And then for the specular, I'm going to go with kind of a pale orange. You can also try adjusting the light position, but I think that original position looks okay. So I'm going to leave it at that. Now it's time to animate a few parameters. We'll start with the wave that's controlling where the column gets cut off. So let's go to that wave field, select it, open the editor tools with Alt-Shift-R, and then under Animate with Speed, we're going to choose Phase. Then on the speed generator, drop the speed down to maybe 0.2. Maybe even a little bit lower, 0.1. Next, we'll animate the rotation that's applied before the iterated transform. Let's go to that axis rotate operator. I'm just going to make a little bit of room here. Select the axis rotate, open the editor tools with Alt-Shift-R, and then under animate speed, we're going to choose rotate. Since we're dealing with angles in degrees, we're going to want larger values. So let's increase the value multiplier to 30, and then we can drop the speed down to around 0.3. Now that we have the animation set up, you can see that there are some rotation values where a lot of the shape ends up disappearing, with areas there just kind of fading out of existence. So if you like that, you can just keep it as it is. But if you want to make sure it stays fairly solid, you can make the original cross-section shape a little bit larger so that it fills in some of the gaps. So let's go to our block across and increase the rounding a bit to around 0.5. And let's also adjust the offset in the iterated transform. So let's adjust the X and the Y translate a little bit here. So I think it looks a little bit better spread out to around maybe 0.5 for X, and then a little bit lower to around 0.05 for the Y. You can also try animating these, but it can be a little bit tricky to do that without having the shape disappear at some point in the animation cycle. So you need to be kind of cautious about that. And that's it for our scene. To recap, we're using a 2D SDF that's being rotated and then fed into an iterated transform, which is adding that kind of fractal effect. We're supplying our own type of symmetry in there using a modular polar with the custom transform input. And then we are extruding that along the y-axis and cutting it off using a plane that's rippling based on a sine wave. Then we are applying a material to that, modular material with some diffuse and specular shading. And then finally, we are rendering it out with the Radial Symmetry 3D. There are lots of other things that you can try with this scene, like replacing the 2D SDF with another shape, or inserting other types of transformations either before or after the modular polar, so that that gets included in the iterated transform, or try out different ways of extruding it on different axes or different types of cutoffs or different materials and so on. So I look forward to seeing what you all do with the scene. And if you post on social media, use the RayTK hashtag. And at least on Instagram, tag me to make sure that I see it if there's stuff that you want to show off. If you want to support RayTK development, check out my Patreon. You'll get early access to tutorials, exclusive scene downloads, and more. Thanks for watching, and as always, make sure to like and subscribe.